Friends, myself, Mr. B.J. Nalawde, Associate Professor in Electronics, Red Shikshan Sanstha's Sadguru Gadge Maharaj College, Karaj. The topic I want to cover today is from electronics. Particularly, it is basic electricals. In electronics, in electricity, a very common and fundamental basic term is circuit. The circuit is basic term because in electronics work as well as in we design the circuits, we develop the circuits, we analyze the circuit, and even after using the circuit, the fault finding is also important term in case of circuit. So circuit is very basic and important term in electronics. What is circuit? Circuit is any interconnection of electrical components or electronic components, any interconnection of components, but for particular purpose. Without purpose, if we design the circuit, there is of no use. So for particular purpose, if we connect the component together, it becomes the circuit. For example, these are the circuits. Now this circuit, it includes, this is the DC supply, few resistors are there, additional load is there. This is also circuit. It consists AC source and load is there. So for particular purpose, if we combine this component together, it is a circuit. Any circuit, important thing is that any circuit having three parts, most important three parts. One is source. That means here in this circuit, this DC battery of 10 volt, it provides power to remaining circuit. It gives energy. So it is known as a source. And here, this 15 ohm RM load, it absorbs this electrical energy. It utilizes electrical energy. So it is known as a load. So the purpose of circuit is to provide power to the load from the source. It is the purpose. So for this purpose, we have combined this component together. It is a circuit. It consists three basic parts. One is a source which supplies electrical energy. Another is load which utilizes. Suppose it is a bulb. It uses electrical energy. The filament becomes red hot and then gives light. That means bulb is load. Battery is the source. But what is use of this middle part? It is the carrier part. If the required power for the load is equal to the supply, then only connecting wires are connected. Only wires are connected. That means source gives energy and load absorbs total energy. So only it is connected. So connecting wires are there. But sometimes what happens? Energy of source is more and load requires small amount of energy. That's why there should be some reduction of energy. For this purpose, this type of network. Even in some cases, the load requires large energy and source having small energy capacity. In this case, amplifier type intermediate circuit network is used. So this is the circuit. Circuit basically consists three parts: source, load, and the carrier or intermediate network. Now, difference in these two circuits. In the first circuit, we have used the DC battery, DC source. That means it has fixed polarity. Upper terminal is positive, lower terminal is positive. So it is a DC supply, DC source. And this is the AC source. Its polarity is not fixed. It becomes positive, negative, alternate. That's why the upper source, this DC source, it provides constant current and its direction is same throughout the time. It provides current from positive terminal and it goes to the negative terminal. It is the conventional current. Actually, there is a flow of electron from negative terminal to positive. But conventionally, we mention that the current flowing from positive. So, direction of current is constant, magnitude is constant, and also the voltage magnitude is constant. It is a DC source. The source which having magnitude and direction constant, it is a DC source. And source which magnitude varies and direction also varies. Suppose upper terminal is positive, then current direction is this. But when the polarity changes, if upper terminal is negative, lower terminal is positive, then current direction. So direction changes, magnitude changes, that's why it is AC. So AC and DC, these two sources we have used in these two circuits. So loads are there, different loads we use, different components we use, and different sources also we can use to design the circuit. Now important thing is that first I want to explain the electric energy sources. There are two types. You might have known these two types, AC and DC. AC means alternating current source and DC means direct current source. Out of this, AC is very important because 99% of energy we utilize in day-to-day life is from AC source. It is provided in our state. The energy is provided by Maharashtra State Board of Electricity, MSEB provides AC for us. And only few appliances, even equipments like mobile, computer, transistor, TV, they needs DC supply. But this DC is also obtained from AC. That's why AC supply is very important. AC energy alternating current supply is very important. Now this again I have shown the same circuit. This is the AC source. Any type of load we connect for this AC. This may be a fan, this may be a bulb, this may be a tube or any device, even deep freeze or any home appliances we can connect to even heater also. So this is the AC circuit and this is the AC source. Here again I have mentioned 90% of electrical energy we use is the AC energy, and of course it is a direct current source. It provides direct current in the circuit. Now AC, there are two types of AC sources, single phase AC and three phase AC. Everybody, even the science person or technical person, must know single phase AC and three phase. Sometimes the student or common people consider that if there are only two wires it is a single phase, and if there are three wires it becomes three phase. It is not. Actually single phase and three phase AC supplies are totally different. Single phase and three phase. So we can set the boundary for this application boundary when the requirement, power requirement is less than 2000, approximately 2000 watts. That means home applications. The power requirement is about 1000 watts. If power requirement is below 2000 watt, the single phase AC supply is sufficient. But if the power requirement is more, particularly in industries, farmers, water pumps, the power requirement is large. In this case, three phase AC should be there. It is required. So two types of electrical AC energy sources, three phase and single phase. Single phase consists only two wires. One is phase wire, another is neutral. Neutral means, as its name suggests, it is total neutral. There is nothing polarity also. Neutral is simply neutral wire. Only one phase wire is there. Phase carries the current, phase carries the electrical supply. So phase supplies the current and neutral is used for the return path in single phase AC. And in three phase AC, there are three independent phase wires we use. Now this supply is a single phase AC source. It has a phase terminal. So it phase terminal automatically becomes positive, negative, and this is a neutral. It is totally neutral. But when this goes positive, neutral acts as a negative. Actually, only phase terminal polarity changes. So these two wires are important in case of single phase power supply. This phase wire and this is the neutral wire. And for every load, for every appliances, these two wires must be there. Suppose we want to start tube light. Two wires must be there. One phase wire, one neutral wire, and when circuit completes, tube gives light. For the fan, two wires are essential. So this is important. Two wires are there, and again I want to explain in detail how this AC acts. This single phase AC source acts. Actually, this single phase AC we can show or we can represent it with the help of sine wave, because its single phase AC, variation is according to the sine function. That's why it is given as a sine wave. This is a single phase AC. That means the phase terminal, its polarity vary like this. Polarity starts from 0, goes to maximum, then again 0, then goes to negative maximum, then 0, period. This completes one wave. This completes one wave. And such type of 50 waves completed in 1 second. That's why the single phase AC or 3-phase AC also, we term its frequency is 50 Hz. Frequency means such type of number of cycles per second. That is frequency. So frequency of AC in India, even most of the countries, the frequency of AC is 50 Hz. Now another important specification is amplitude. Amplitude means the peak to peak amplitude. From this to this, it is known as a peak to peak amplitude. Or half of this, it is a positive peak. It is this is known as a peak amplitude. This is related with voltage. Voltage means amplitude. If voltage increases, its amplitude increases. And if frequency increases, that means in 1 second, number of cycles going to increase. So frequency, phase, then any such supply, it provides the current according to the source. Source has the current capacity. Some sources having small current capacity, 500 milliampere, but sometimes the load requires 10 ampere current. Then same source we can't use. The source having the voltage, important parameter, as well as its current capacity, it is also important. So voltage and current, these parameters related to users. User must know its voltage and its current capacity. But the frequency and phase, these are the parameters related to technical persons. Actually, frequency is also very important term. It is used in AC energy distribution, for the distribution of purpose. That means for the load shedding or shutting down different generators to control overall AC supply in the region. The frequency term is useful, but it is for the technicians. Phase means if there are two AC sources, then suppose this is the one source and another source is like this. If this is the another source, that means this is the source A, this is source B. We can say that the two sources are same, but there is a phase difference. The A leads to B by 90 degree or B lags behind A by 90 degree. So this is the phase. But this is important term for the technicians. For common people, the most important thing is that what is the voltage of AC and what is its current capacity. These are the important terms. In India as well as in most of the countries, the standard voltage is 230 volt and frequency is 50 Hz. So these are the important parameter we must know. The standard voltage must be, even our appliances, all the electrical appliances, these are designed to operate for 230 volt and 50 volt. On the other hand, in America, the devices are developed to operate with 120 volt and 60 Hz because they utilize the voltage and frequency. These terms are in America and some European countries, 120 volt and 60 Hz is the related frequency. So devices are designed accordingly. In India, all the devices working with 230 volts, even plus or minus 10-20% is allowed. The devices work from 200 volt to 250 volt. But if the voltage below 200, device doesn't work and we say that the light is dim and we are not working with this light. So most important is 230 volt is the voltage must be there. Now for this AC, again these terms are important. This I have shown the generator, AC generator, hydraulic power generating station diagram. It consists the water bank, that is a dam. In even our district, the Koyna dam, we know there. This is the water flow, with very high pressure. When water comes on the turbine rotates. That's why this generator arm, this generator turbine or axle rotates in the magnetic field, and automatically the electric energy is generated, and this electric energy is carried through line wires. Note that we require the AC voltage of 230 volt, and the required current we want, current that is from few microamperes to 20-50 amperes, the current requirement is there. So we require 230 volt and current capacity. If the same voltage value is generated there is a problem in transmission, because what happens if the low voltage 230 volt and high current is generated there, then there is a loss of power in the transmission path. Transmission wires, these are metallic wires, but they are having certain resistance. So I square R is the power loss. So most of power get wasted if the same voltage is generated, 230 voltage. That's why at the generating station, very high voltage is generated, about 2200 or 4000 volt. So high voltage is generated there, and low current, high voltage and low current, this is the generated values, and then it is easily transmitted with minimum loss. So when this type of high voltage and low current power comes to our village, then it needs such type of transformer. Commonly we know this as a DP. In the outside the village there is a transformer or DP. Near to residential zone there is a DP, because this DP or transformer converts this high voltage. High voltage is not useful for human being. We require 230 volt, but available voltage is very large for a transmission purpose. That's why transformer is used to reduce the high voltage to low voltage. Then it provides our required voltage and desired current. When this electrical energy comes to our homes through the wires, these are electric poles, through two wires, there is a single phase AC supply coming to the residential, given to residential, single phase AC supply, phase, and there is a neutral. Two wires are sufficient. It comes to first, this is the electric meter. For metering, for a customer, in order to generate the bill for utilized power, the meter should be there. So two inlet wire, two outlet wire, it is a meter. And then the second part is, this is the circuit breaker, protection circuit. This is the home arrangement, the fan, the lamps we are using. This is the home internal fitting. But this is the protection circuit. This is not for MACB, but for protection of our home. Because when by any accidentally if two wires get shorted, or our any device goes out of order, or it goes wrong, sometimes overheating is there, and there may be possibility of short circuit or even firing also. And that's why this protection circuit, old protection circuit, the fuse wires are used, or we can main switch and fuse wires are there. When overcurrent flows through the circuit, due to any reason, automatically fuse burns and circuit breaks. But nowadays, modern technique is MC, miniature circuit breaker is used. What happens when overload happens? This MCB automatically switches. MCB turns off and it breaks the circuit. When we remove the fault, when we correct the internal circuit, then we set the MCB. So this is the protection circuit. Again, for any equipment, two wires are essential, phase wire and neutral wire. So neutral wire is directly connected to all the equipments, directly given to all equipments. But phase is given through the switch, because we want particular device may be on or off as desired. That's why to make the particular device on off as desired, the phase is given through the switch. So this switch, it controls the action of first bulb. This switch is control action of fan. When switch is off, there is no phase for fan, and when switch goes on, the phase goes to fan and fan works. So in this way, electric wiring is there. single phase AC supply has most of the most commonly we use, very commonly we use residential supplies are single phase AC supplies. Domestic appliances are designed to work with single phase 230 volt and 50 hertz, and their design operation is also simple, and this single phase AC supply is sufficient up to 2500 watts. But another, this is also important supply, this three phase supply. Even for the home application single phase is sufficient, but if we consider the college plenty of devices, number of computer laboratories, and then single phase AC supply is not sufficient. In the college, in our college also, three phase AC supply is there, even separate DP transformer is there, three phase supplies we are utilized in the college also. So three phase, note that it is similar to single phase, it provides electrical energy, its variation is same, frequency is same, only there are three phase lines for the provision of high power. It is important. So there are three power wires, three phase lines. Additional fourth wire is there. If star type connection is there, a common wire, neutral wire is there. So sometimes this supply is available through three wires, and sometimes the supply is available with four wires. So this is the three phase waveform. Here R, Y and P, red, yellow and blue, these are three phase, and every phase is differ by 90 degree. This red and yellow differ by 90 degree, yellow and star differ by, but total angular difference is 120 degrees Celsius between the three phases. So these are the three phases. There are two types of connections with this three phase supply is available. One is delta connection and another is star connection. This is about diagram. So delta connection. Delta connection, there is no neutral wire. Only R, Y, B, three phase wires are there, and this is sufficient to drive the electrical motor, heavy motor, because each phase happens at 120 degree. It produces the torque and motor rotates. So for heavy loads, this delta type connection we use with three wires. And this is a star type, simply looking like a star. There is a three phases are combined together, and it is a neutral. So R, Y and P, these three phases with additional. This is the star connection. We can use star connection also for the running in heavy motors or in industrial applications. Note that between these two phase terminals R and B, or B and Y, or R and Y, the voltage is 415 volts. Voltage between two phase wires, and voltage between any phase and neutral is 240 volt. Okay. What are the advantages of three phase? This less wiring is required as compared to single phase. Commercial, industrial loads, easily we can run with the three phase. Very easily to easily run longer loads. Large three phase motors, even if the motor is working with single phase or small motors are there, starter is essential to produce the initial jerk. But heavy motors, they do not require the starter. The overall efficiency of three phase is very large. Efficiency means it can generate 90% of it can convert 90% of electrical energy to the mechanical power. These are the advantages. Now these are the simple differences. Single phase means two wires, phase and neutral. Three phase means three phase wires, fourth wire is neutral if star connection is there. Single phase supply is 230 volt and three phase supply is 450 volt. Single phase supply requires more wire than three phase supply. The efficiency of three phase power supply is more than single phase supply, and complexity of three phase supply is more because there are three phases with the neutral. Another important terms in case of AC supply is RMS value. For AC, we know this is a AC, single phase AC supply. So what happens? how the voltage is calculated is problem. Single phase AC supply start from 0, increases, then minimum it becomes. So if we the value is not constant, which value is taken? If we take the average, there is a problem, because the same amount of positive values equal to same amount of negative values. The average becomes 0, and that's why the standard value, RMS value, is taken. Root mean squared value is given. RMS value. RMS value is also termed as the effective value, because the same value of the AC voltage which produces the same effect of the DC voltage. That's why it is also known as an effective value also. RMS value and effective value. So how RMS value is calculated? For this purpose, again, suppose this is AC voltage and its peak to peak voltage is Phi peak to peak. Then peak to peak value, measure the peak to peak value divided by 2 root 2. It gives RMS value. Or simply the peak value divided by root 2. It also gives RMS value. And the final calculation is 0.707 into Phi peak or maximum. It also gives the RMS value. Now, important term is power. We have said that the bulb is of 25 watts, tube light is of 40 watts. The power calculation is important. How to calculate power? If in any circuit voltage is known, current through it is known, then I square R is the power, or voltage square divided by resistance. It is also equal. Power is equal to voltage into current. But current is equal to again V divided by R. So V square divided by R is also power. I square R, it is also power. Or V into I, it is also power. Now this is a simple example. Battery of 12 volt, if supplies the current of 0.9 ampere, then power in the circuit becomes P is equal to V into I. 12 volt into 0.9 ampere. This is about 10 watts power dissipated. Even in electric bulb, we can easily calculate the power dissipated. We can use the ammeter in the series of electric bulb. So current into voltage directly gives the power dissipated in the circuit. So this is all about AC supplies. Note that in single phase AC supply, only 2 wires are there, phase and neutral. Additional earthing wire is there, but this is not part of the electrical supply. Earthing or ground wire is for protection of human being and even instrument. It is used. Suppose in our plug, if there are 3 wires, one phase, then neutral, and third wire is earthing wire, it doesn't mean that it is a 3-phase supply. People commonly interpret this as a 3-phase because there are 3 wires. It is not actually. There are only single phase. Phase and neutral is important, but earthing is essential. Suppose any device is become internally short circuited. That means phase gets shorted to body. What happens? It is hazardous for the person working with this device. But if there is earthing connected to body, automatically fuse burns and supply breaks. So it is single phase AC supply. So earthing is different from single phase, 3-phase. This is another type of power supply. This is another power supply, direct current source. But we saw DC supply. DC supply, it has fixed polarity, fixed direction of current. That's why DC supplies. Now there are 2 examples are simply batteries we are using with digital watches, or even in our mobile battery is there. This is the DC supply. It has fixed positive and negative polarity, batteries. Now there are 2 types of this DC supplies, DC batteries. One, primary cells or batteries. These are non-rechargeable. They can be used once, use and throw. Okay. And another batteries are secondary batteries, rechargeable batteries. These are also particularly in vehicles, vehicles for the starting of the vehicle. The secondary batteries are commonly used. Even in UPS system, secondary batteries are used because these are chargeable. They can be reused. Their life is long, but initial cost is large. Secondary batteries. So these are the two basic types. Now the primary batteries or non-rechargeable batteries are of different types. First type is alkaline batteries. These are constructed using chemical composition of zinc and manganese oxide. For the electrodes, external electrodes, metallic alloy elements are used, and their power density is 100 watt per kg. So this type of battery we commonly use in torches, digital watches. Their advantage life cycle is more. For the digital watch, even battery works with 1 year also. More compact, efficient for portable device, small in size, highly efficient. One important term is for every source, either for DC or for AC. There is one additional term the technical person must know. Additional term is its internal resistance. Every source has its internal resistance, because when we connect it in the circuit, the total current is voltage divided by total resistance. While considering total resistance, the external resistance plus the internal resistance of battery must be included there. So the internal resistance of battery, it is also important. If the battery internal resistance is very small, it is known as a voltage source. And if the battery internal resistance becomes large or goes large, or initially if it is large, it happens to be a current source. So same cell, same battery can be used as a voltage source when it is a new, and when it is in use, its internal resistance goes on increasing, and then it becomes current source. This is also important. So we must know every battery, every cell, it has some internal resistance. Another type of this DC batteries, coin cell batteries. The chemical composition is alkaline one. It consists lithium and silver oxide, the combination, and it has power density of 270 watts per kg. This type of structure is commonly, particularly the MOS cells, even small equipments, portable equipments, they are using this type of batteries. Small in size, high power density, low cost, nominal voltage is about 3 volt. But this disadvantage is that they having very small current capacity. They are unable to drive the high loads, unable to drive. And one thing is that they always requires a particular holder while using. This is a common form of secondary battery, rechargeable battery. We are using such batteries in UPS systems, even our two-wheeler battery or mobile vehicle battery. This type of batteries are used. These are secondary batteries. Lead acid battery, because it consists lead acid as a chemical composition. The nominally these batteries are available from 2 volt to 24 volt, 12 volt batteries, 6 volt batteries. These are examples, and the power density is very high, 7 watt hour per kg. Cheap in cost, easily rechargeable, high power capacity. These are the advantages. Applications, no doubt, in UPS system, heavy machinery, mobiles, in starters, such type of batteries are used. NiCd, nickel cadmium battery, these are very popular, particularly in mobiles. NiCd batteries are used in different, these are shown NiCd batteries. In different format, these are also nickel and cadmium chemical composition is. These are very cheap. The nominal voltage is 1.2 volt and power density is also at 60 watt hour per kg. The advantages: cheap in cost, easy to recharge. Any environment, any situation, we can use these batteries, and they comes in a very small standard size. But disadvantage: low power density, and the internal chemical composition is toxic. It is hazardous for human being, and frequently charging is required. There are some applications are in toys, cordless phones, solar lights. These batteries are these lithium ion batteries. No doubt it consists lithium as a chemical composition. These are also in compact size. This is the shape of the battery, available with 3.7 volt, and its power density is 126 watt hour per kg. They are having advantages: light in weight, power density is high, cell voltage is high, and disadvantages: these are expensive as compared to other batteries. Application: power bank. Mobile power banks are developed with one disadvantage of this battery is that when the battery two terminals get short circuited, then battery explodes. Some commonly we might have listened some examples that mobile burst or battery explosion. So this type of battery, this is the disadvantage of the battery. Okay. So battery ratings. Every battery has some rating. Rating means the current capacity is important. The rated capacity of battery is average amount of current it gives for a particular span of time period. Suppose 20 ampere current battery provides for 10 hours, then the current its rating is 200 ampere hour. And the battery chargers are simply rectifier circuit. These are used to charge the secondary batteries. Okay.